Hey everybody, thanks for clicking on this video. Today we're going to be practicing adding and subtracting rational expressions with multiple denominators. If you want to follow along, the links to the companion worksheet are in the description below. Also, you can click the subscribe button just to stay tuned on all the things we have coming out from the channel, so don't miss out. So let's get started. So, what do we mean by multiple denominators? Well, in the previous video, we talked about adding and subtracting rational expressions with equal denominators, where all you have to do is perform the adding or subtracting operation to the numerator and leave the denominator alone. So now we ask, what if the denominators are different? Now, in this specific video, we're going to deal with instances where the denominators are multiples of each other. In the next video, we're going to deal with denominators that are totally dissimilar, or we call them co-prime. So here in this first one, this denominator is 5, this denominator is 10. So we need to make them equal, because that's how adding and subtracting works. They have to be adding or subtracting like things. So that means here we need to multiply this fraction, top and bottom, by 2. But we're going to leave this one alone. So if we multiply this by 2 on the top, that's going to be 4x plus 6 all over 10 minus 2x plus 1 all over 10. Now that they have the same denominator, now we can combine them. So it's the quantity 4x plus 6 minus the quantity 2x plus 1 all over 10. So now we're taking 4x and we're subtracting 2x because we have to combine like terms. So 4x minus 2x is 2x, and then we take 6 minus 1, so that's plus 5, all over 10. And there's nothing we can take out of the numerator, so this is in simplest form. Looking at number 2, this type of problem often gets people because they see one fraction and they don't see another. Well, you can always think of 4 as 4 over 1. So in order to get the same denominator here, what we have to do is we have to multiply this, top and bottom, by 10. So when we do that, we get 40 over 10 minus 2x plus 1 all over 10. So, as a single fraction, that's going to be 40 minus the quantity 2x plus 1 all over 10. Now, this doesn't have an x term, but we are subtracting 2x. So that means we have negative 2x, and then 40 minus 1 is 39 over 10. And negative 2x and 39, they have nothing in common, so we can't factor anything out of the numerator. So there's our simplified answer for number 2. For number 3, here our denominators are 5x and x. Now the rules still apply whether we have numbers or we have expressions with variables. So both denominators have an x, but this one has a 5 and this one doesn't. So we're going to have to multiply this expression, top and bottom, by 5. So we have 2x plus 1 over 5x. We're going to leave this one alone. For the second one, we have 5x plus 10 over 5x. Now, you always have to be careful when subtracting to be sure that you include negatives, but when you're adding, it's a little bit easier. We can just say 2x plus 5x, that's 7x. And then 1 plus 10 is 11, all over 5x. Again, when we add or subtract rational expressions, the denominator stays the same. Here, we have our denominators of x and x squared. So that means we need to multiply this by x on the top and on the bottom, because this has one factor of x in the denominator, this has 2 of them. So in order to get a common denominator, this one needs a second. So we have x squared minus x. When we multiply that on the top, then we have x squared in the denominator. We left this one alone, so this is x plus 1 all over x squared. Now we're adding, so we have x squared on the top. There's no x squareds here. Negative x plus x, those cancel out. And then plus 1. So x squared plus 1 all over x squared. These two, x squared and 1, have nothing in common, so there's nothing we can factor out there. So we just leave it as x squared plus 1 all over x squared. Number 5. This one is a little bit tougher because we have to do a little bit of factoring. We have to factor this expression right here, 1 minus 4x squared. So I'm going to rewrite it. So 1 over 1 minus 2x plus 2 over, and now we put in parentheses. So how does this factor? Well, this is a difference of squares. So the square root of 1 is 1. The square root of 4x squared is 2x. So plus 2x and minus 2x. So now we can see that both denominators have a 1 minus 2x factor, but this has a 1 plus 2x factor that this doesn't. So that means we have to take this fraction and multiply top and bottom by 1 plus 2x. Now when we have multiple algebraic factors, leave them in factored form. Do not expand them out. It makes it harder for you later on if there's a possibility of canceling things away. So just leave this like this. This is going to become 1 plus 2x all over 1 minus 2x times 1 plus 2x plus 2 all over 1 plus 2x times 1 minus 2x. So now we have the same denominator. Now remember, multiplication is commutative. So the fact that we multiply these in different orders, that's okay. Multiplication works. So we have 1 plus 2 is 3, and then 2x plus, there's no x here. So that means we have 2x plus 3 all over 1 plus 2x times 1 minus 2x. 2x and 3, they have nothing in common, so nothing can be factored out and nothing can be canceled. For number 6, here we have x plus y and x plus y squared. Now another way to think of this is x plus y times x plus y. So this fraction has 2 factors of x plus y in the denominator. This first fraction only has 1. So we need to multiply by a factor of x plus y onto this fraction on the top and on the bottom. So we have 4x plus 4y all over x plus y. Now instead of writing x plus y times x plus y, it's faster and easier for us to write quantity squared. So I'll do that. So here we have x plus y quantity squared. All right, so now that we have the same denominator, we can combine like terms. So 4x and 4x give us 8x, and then we have 4y. So we have x plus y quantity squared. Now in this instance, we can factor a 4 out of the numerator, so we'll do that. And we're left with 2x plus y all over x plus y quantity squared. Now unfortunately we can't cancel because this quantity is not equal to this, because there's 2 x's in here as opposed to 1. So can't cancel, but at least it's factored. For number 6, this one is similar to an earlier one where we had a rational expression and an integer. We're going to do the same thing that we did here. This has a denominator of x plus 4. Think of 3 as having a denominator of 1. So we need to multiply this by the quantity x plus 4 on the top and on the bottom. So 2x plus 3 all over x plus 4 minus, it's going to be 3x plus 12 all over x plus 4. Now the thing to remember is that we are subtracting quantities. So let me write it like that. 2x plus 3 as a quantity minus the quantity 3x plus 12 all over x plus 4. So now 2x minus 3x is negative x. 3 minus 12 is negative 9 all over x plus 4. Now, in this problem, we have a negative that we can take out. It's often a good rule of thumb to take out negatives when you can, because negatives often make it harder to see if you can cancel something. Now, in this case, you can't cancel anything, but it's good form to take that out. For number 8, take a look at, we have 2x plus 1 over 5x minus 1, and then we have 3 minus 2x over 1 minus 5x. Now this one is here because this really is what messes people up a lot, because these two are opposites of each other. So we could think of 1 minus 5x as negative 1 times 5x minus 1. We could think of it like that, which means that all we would have to do is multiply this first fraction by negative 1. And so if we multiply this first fraction by negative 1, that would give it the extra negative 1 factor we need, and then they have a common denominator. So if we do that, that's going to be negative 2x minus 1 on top, and then it's going to be negative 5x plus 1. And then we leave this alone, 3 minus 2x over 1 minus 5x. Now just to clear things up, what I'm going to do is I'm going to rewrite this denominator. I'm going to rewrite it as 1 minus 5x, just so you can see that it is indeed the same denominator. So now we're adding the same denominators with same denominators, so negative 2x and negative 2x is negative 4x. Negative 1 and 3 is positive 2, all over 1 minus 5x. Now, we have a 2 that we can factor out, but x, the leading coefficient, is negative. So one good thing to do is to take out a negative. So negative 2, and then we have 2x minus 1 over 1 minus 5x. And then finally, here we have 3 over x squared plus 2x plus 1 plus x plus 1. Now this can be factored into x plus 1 times x plus 1, which is just x plus 1 quantity squared. So this has 2 x plus 1 factors, this only has 1. So when we multiply by x plus 1, we're going to multiply that onto this second fraction. So 3 over x plus 1, and we'll write that as squared. And so here we're going to have x plus 1 on the top, and then x plus 1 quantity squared on the bottom. So now we can combine these because we have the same denominator. There's no x here, there's an x here. So we have x. 3 plus 1 is 4, all over x plus 1 quantity squared. And x and 4, they have nothing in common, nothing to factor out, so that is simplest form for that answer. Thanks everyone for watching. If you like the video, please give it a thumbs up. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching, and remember, the best way to understand something is to do it.